All right, so now for 83, it says a displacement vector of 34 meters in length is directed 60 degrees east of north. So let's write this down. This is north, east, south, and west. And 34 east of north. So this is north, and this angle here is 34 degrees. And it has a magnitude of 34 meters. What are the components of this vector? So now to break down this vector, I'm going to have a north component and I'm going to have an east component. Now to find those, I got to treat it like it's a right angle triangle. What's this one right here, opposite or the adjacent? Opposite. What's the 34?
Wait, isn't it 60? 34 is adjacent.
Oh, it's 60, yeah. I don't know why it's 34 degrees. What is this one, though? This is the hypotenuse, right? And then this is the adjacent. And for some odd reason, I wrote down the wrong angle. So it's 60 degrees. So now to find the east component, let me remind you. So the opposite is sine. So sine of theta is equal to the opposite over the hypotenuse. But if you multiply both sides by h, you end up with h sine of theta is equal to the opposite. And that's what I want to know, because that's the east component, right? So I'm going to say 34. Oh, I see where I got that, why I screwed that up. 34 meters times sine of 60. And now to do the north, I'm going to do the exact same thing, except it'll be cosine. All right, so get out my handy dandy calculator. I should be in degree mode. 34 sine of 60 equals 29.44. So let's check that one. So that was for east, 29.4. That's the east component, is the 29, it's this one. And so if I'm doing this right, my next component should be 17, right? Because I think it's this one. I think it's option number 4. Okay, so let's see. We're going to do cosine now. 34 times cosine of 60 degrees. Yep, 17. All right, so I think it's option number 4. Boom.